Using the comparison test, we are able to solve for series that seem difficult at first to solve for, but in reality, it's relatively simple. So we have the series k squared plus k plus 5 over k to the third plus 3k plus 1. If we were to take the limit, so basically the divergence test, see if this equals 0 or not, we would, well, hold on, let me show you. Limit as k approaches infinity, k squared plus k plus 5 over k to the third plus 3k plus 1. This right here will be equal to 0. This means that the divergence test is inconclusive. So we're gonna have to use another type of test. And that's when the comparison test, the direct and the limit versions come in. So you have this series right here starting at 1 going on to infinity. And you have this series right here. And we could call this right here a sub k. So what we can do is we can set the whole thing equal to the series of a sub k. Now we have to come up with the second series, and we're going to call it b sub k. And we're going to use the direct comparison test, which says that if there's two conditions. If b sub k is less than a sub k, series of b sub k is less than the series of a sub k, and b sub k is the series of b sub k diverges, then a sub k will diverge. Now, if the series of b sub k converges, that doesn't tell you anything about a sub k. Now we can use this scenario. Series of a sub k less than the series of b sub k. Now if b sub k converges, a sub k will converge as well. But if b sub k diverges, that doesn't tell you anything about a sub k. Those are the two, those are basically two requirements, or basically a theorem. So we have this series right here, series of b sub k, and we have to figure out how we can get b sub k to either converge or diverge. So what we can do is we can look at the leading terms, which are k squared and k to the third. And we can make a new series based off of that. K equals 1. Okay, starts at 1. So k squared divided by k to the third. This is how you come up with your new series. Equals, we can simplify this down to k equal, the series of k equals 1, starting at 1 to infinity. Now this simplifies down to 1 over k. Well, using the p-series test, or if you're able to tell, it's a harmonic series, meaning it diverges. So we could say diverges by p-series, or it's harmonic. Okay, we know that 1 over k, the series of 1 over k is less than the series of all that, well, all this right here. We can just, let me just erase all of this because it is a lot simpler. Series of b sub k is less than the series of a sub k. And the reason we know that is because you have a small degree of a denominator there, and the smaller the denominator is, the bigger the overall fraction is. But the thing is, you're looking at based off of the leading terms of this series right here. So we can ignore all this right here. We can just ignore all that. And we know that 1 over k is less than all this by basic algebra properties. So let's see. Let's try 1 over, let's just plug in 2, 1 over 2. Now 2 to the second power divided by 2 to the third power. That's 4 over, what is that, 2 times 2 times 2, that's 8. Well, it's basically the same thing. Not necessarily less than. But here, we have additives to the denominator. We also have additives to the numerator. So let's try that out. So let's see, plus 2 plus 5. And then what is this? 6 and 1. Let me get my calculator. 4 plus 2 plus 5 equals 11 divided by 8 plus 6 plus 1. Oh, hold on, let me fix this. 8 plus 6 plus 1. Okay, yeah. This approximates to about 0.733. And this shows that this series right here, the series of a sub k, will be basically bigger than the series of b sub k for all your numbers. So yeah, you know that this right here, that, oh my bad, this 1 over 2 is just basically 0.5. 0.5 is less than 0.733. That's basically proving that a sub k is bigger than b sub k. Okay, now let's go back to this. So what do we know if b sub k diverges? Well, we know that if b sub k diverges and is less than a sub k, then a sub k will diverge as well. So we can write this as a if and case. If and then. So we can say if b sub k, or a series of b sub k, diverges, and the series of b sub k is less than the series of a sub k, then a sub k diverges. And we can write this as the little 3 dots basically says, in conclusion, series of a sub k diverges by direct comparison test. Line right here to separate. Purple to highlight, and green to highlight the answer. There we go. Now let's go on to question number 2. Question number 2 is a series starting at 1, going to infinity, of 1 over 7 k to the 7 plus 9. Now we can call this our series of a sub k. Now we have to come up with the series of b sub k. You have to kind of look ahead and see if this series, we're trying to get it to converge or diverge. Well, we see the leading term right here, because we can start a new series, k starting at 1 to infinity. We can take the ratio of the leading terms again, and this is 1 over 7k. We can ignore the plus 9. And this right here, well, we can just move the b sub k right there. We know that by the p-series test, if p is greater than 1, then series will converge. Converge. Now, if p is equal to or less than 1, then it will diverge. So we can say that this converges by p-series. So what do we know? If, well, let's look at it just like this. 7k to the 7 plus 9 is greater than 7k to the 7, right? If you were to put, let's just say 1, make it simpler. If you plug in 1 for your 7, then that would be 7 is less than or equal to 7 plus 9. That is true. So if you know, oh, hold on, let me undo that. If you know that this right here will be bigger than this, what would happen if you put the right part as a denominator? That will make the overall fraction, oh my bad, so 7 plus 9. That will make the overall fraction different. So basically the sign will flip like that. So knowing that, we can go back to our series and see what it looks like. So we know that if you have 7x, oh my bad, if you have 7, no, it's not 7x, 7k to the 7 as your denominator, that's a smaller denominator, meaning your overall fraction will be greater than the other one with the bigger denominator. Okay, if we know that, then we know that the series of b sub k is greater than the series of a sub k. Series of a sub k is less than the series of b sub k. Knowing that, we can look back our b sub k and see if it converges or diverges. Well, we know that it converges by p series, so we can conclude that the series of a sub k will also converge. So let's go back. We can write it as a if and then case. If and then. If b sub k converges and a sub k is less than b sub k, then a sub k converges. Now we can write in conclusion, hold on, a sub k not a sub k, the series of a sub k converges by direct comparison test. You can write a line right there to separate from the next problem. Highlight the answer in green, highlight the question in purple, and we can go to the next one. Now there's another version of the comparison test, and it's called the limit test. Now here I'm gonna have to write down the definition for this one. So we can call three different cases basically. Positive, finite number case, infinity case, and this one I'm gonna limit here. And the zero case. Okay, so for the positive finite case, we can say that if, while taking the limit of the two series, it can be b or k or whatever, as k approaches infinity, equals a finite number that's positive, let's just say 3 for example, and a sub k, hold on, if b sub k converges, then a sub k will converge as well. That's the positive finite case. The infinity case says that if your limit goes on to infinity, as k approaches infinity, and your limit goes on to infinity, then b sub k diverges, and if b sub k diverges, then your series of a sub k will diverge as well. In your zero case. Zero case states that if your limit as k approaches infinity equals 0, and b sub k converges, then a sub k will converge as well. One more thing, going back to the positive finite case, this says that if your limit is equal to a positive finite number, and if b sub k diverges, then a sub k will diverge as well. But if b sub k converges, series of b sub k converges, then the series of a sub k converges as well. The positive finite case is the only one that has an either or. So you have to be careful when you basically get a positive finite number. The zero case, that happens when your b sub k converges and your a sub k will converge as well. That's the only time it will be equal to 0. That's if it's equal to a positive finite number, you got to be a little bit more careful because it can be either diverging or converging, just depending on your b sub k. And your infinity case is pretty simple. If your series of b sub k diverges, then a sub k will diverge as well. Those are basically 3 cases. Okay, now let's go to one that actually uses these cases. Let's start with, let me see. Let's start with the simpler looking one. Okay. Oh yeah, I like this one. Wait, no, hold on, not that one. Not that one. Oh, that one's ugly. Can't seem to find one. I have an idea, hold on. Okay, this one's perfect. Okay, here we go. So we have the series. We can use n or k, whatever terms you like. Well, basically whatever letter, as long as you keep it consistent. So 1 over square root of n squared plus 1. And this is your series of a sub k. Now let's get a series for b sub k. So we can achieve this by basically getting the leading terms of our numerator and denominator. So that'd be, let me show you this. Okay, n equals 1 over n squared, and square root is just 1 over 2. Saying 1 over 2 to the 1 over 2 power is the same thing as just putting a square root, but it makes it a bit more simple to understand. So this right here, we can simplify it down to series as n equals 1. So basically, when you have an exponent to another exponent, you just multiply them. So it's n, so 2 over 2. Well, basically, 2's cancel out if you multiply them together. So it's like that. So 2 over 2 is just equal to 1, which is just n. 1 over n. And we know that by properties of P series, B sub k will diverge. Okay, now let's use limits. So limit as n approaches infinity, it'll be your a sub. Oh, no, my bad. I didn't mean to put. My bad. It's not b sub k, since we're using n. A to the n, a to the series of a in n terms, and series of b in n terms, basically. So it'll be a to the n over b. Well, not b to the n and a to the n, but series in n terms, basically. So you'll basically your series of a sub n, this right here, and you will divide it by this right here, and basically this right here. Or you can just multiply by the reciprocal. You see what I mean. Okay, now we get limit as n approaches infinity. 1 over n squared plus 1 square root times n over 1. Let me move this little thing right here to right there. Okay, there we go. Okay, now we have n. Oh, hold on. Limit as n approaches infinity. N over. We could just take the leading terms of these two. It like the plus 1 doesn't really affect anything. This right here is equal to 1. The reason that is because this n squared to the 1 over 2, it just becomes n. And this whole thing right here just becomes n. So n over n is just equal to 1. Because it's the same thing as itself. The one thing divided by itself is it's just 1. Now we can write the positive finite case. Positive finite case. The if and then. If series of b sub k diverges and limit equals a positive finite number, then b sub k, a sub k, well not a sub k, a sub n and b sub n will diverge as well. And this is going back to the positive finite case. Remember how I said that if b sub k converges, then a sub k will converge, but if b sub k diverges, then a sub k will diverge as well. It doesn't have to necessarily be a sub k or a sub n or basically any letter you want, as long as you can identify that's the series of the second series diverges and the first series will diverge as well. That's basically all you really have to know. There we go. We don't have to write the in conclusion because we basically wrote what it is, the positive finite case, and we basically state out that it diverges, so we don't really have to write more of an explanation than that. And let me see. Okay, let's look at one with factorial. Your series starting at n equals 0, going on to infinity, 1 over n factorial. Now, this may seem a bit complex right now. Let's just call this series of a sub n. It seems a bit complex right now, but let's just look at something a bit simpler. So we know that n is going to be greater than n minus 1. Just plug in any number. Let's just plug in 2. So 2 minus 1 is equal to 1. That is just less than 2. Okay. So this goes back to the thing to where I said if it has a smaller denominator. Yeah. So basically, if you have the n factorial, this will be bigger than n plus 1 factorial, because this denominator is bigger than this one. Well, how could we get a denominator that's smaller than n factorial, but to where it makes the overall fraction bigger than 1 over n factorial? We can just subtract 1 over n minus 1 factorial, because we know that this denominator is smaller than this one, and this one is smaller than this one. So we know that this one will be bigger than this one, and it will be bigger than this one, this overall fraction. We don't really need the plus 1, because that's just showing an example of where 1 over n factorial would be bigger. So we can just do that as a series. So series, starting at 0, going on to infinity, 1 over n minus 1 factorial. We know that 1 over n minus 1 factorial converges. A sub n, oh my bad. B sub n converges. And it appears to converge by, I'm not exactly sure what test you have to use to convert to know that it converges, but it's just something you kind of learn that this right here converges. So we can take the limit. Is it approaches infinity? A sub n over b sub n. So 1 over n factorial, n minus 1 factorial, and you can basically write out the n factorial and n minus 1 factorial to where they end up canceling out. So we can rewrite this as the limit is n approaches infinity, n minus 1 factorial, n, and the next term would just be minus 1. So minus 1 from the previous term. So if it was n minus 2, your next term would be n minus 3. Like that. So the next term after n factorial would just be n minus 1 factorial. You have this at the bottom and this at the top, so they can cancel. Cancel and cancel. This gives you a limit as n approaches infinity, 1 over n. This is equal to 0. Well, you know that if it equals to 0, we can bring out the 0 case. Zero case, we can write if and then. If series of b sub k converges and limit equals 0, then series of, oh my bad, I did it again, converges as well. Converges. Yeah, I'm sorry. I'm just really used to the K terminology. So, and that's it for this video.